Okay, so let's take a look at an example. This is practice quiz 6, number 3. It says verify the power series. This guy here, this is the same one we have from question 2 in the practice quiz. So this power series is a solution of this differential equation. So in particular, we need to show that x y double prime equals negative y prime plus xy. Okay, so let me write out a few terms of this series. So doing that, we have. So I don't want to write out the first couple of terms here. So when I put 0 in place of n, so that'd be the first term. So it'd be negative 1 to the 0, x to the 0, 2 to the 0, 0 factorial squared. So that'd be when n is 0. And note here that 0 factorial is 1. And then when n is 1, so putting 1 in place of n, it'd be negative 1 to the n. Putting 1 in place of n here, it'll be x squared. Putting 1 in place of n here, it'll be 2 squared. Putting 1 in place of n here, it'll be 1 factorial squared. Well, 1 factorial is just 1. Okay, then putting 2 in place of n here, you'd have negative 1 squared. Then x to the 2 times 2, so it'll be x to the 4. Then putting 2 here, it'll be 2 to the 4, and 2 factorial squared. And it'll keep going like this. So let's work out, let's simplify these terms a bit further here. So the first term then, well, negative 1 to 0 is 1, x to the 0 is 1. So this the first term, this becomes 1. Then this will become negative 1 x squared over 4. And this will become x to the 4th. And this will be 16 times 4. This will be 64 then, and so forth. So when I take the derivative, then the 1 will disappear. So let's note that here. So now when I take the derivative, then derivative of 1 is 0. And this will become 2x in front here. This will become 4x cubed here. So let's take the derivative of the power series up here now. So doing that, we get. So to take the derivative of the power series up here, I just take derivative of x at 2n. So the 2n will come in front. 2n will come in front like I've done here. Then subtract 1 from the power. But the series now will start at 1 rather than 0 like this one, because when I took the derivative, this term went away, so it's gone now. So it's starting at 1 now. So this would be n equals 1 and so forth. Now if I take derivative of this guy to find a second derivative, this would not disappear. This just become negative 2 over 4. So let's do the second derivative here. Okay, notice this should be negative 1 to the n here. I left it off. Okay, so y double prime would be, I take derivative of this one. So I bring the 2n minus 1 now in front. So it'll be 2n times 2n minus 1 to the n, and subtract 1 here, be 2n minus 2 over this guy here. This will start at 1 also, because if I look up here, here's my y prime. If I took the derivative, as I mentioned already, this term would not disappear. This would become negative 2 over 4. So therefore, this would also start at 1. Okay. Now let's start plugging into differential equation up here. So I'm out of space, so let me erase a few things and we'll keep going. Okay, so here's what we have so far. We have our y series, or y prime series, and a y double prime series. And we need to show that this series y satisfies this differential equation. So let's look at y prime plus xy first. Let me do it here. Okay, so I have my y prime series, which is here, which I've written here. Then plus x times my y series, which is here. Now this x can be multiplied in times this x here. You need to add 1 to this up here, because it'd be x times this, add the exponents. So doing that, we get then. Okay, so I've rewritten this guy here, multiply the x in here, add 1 to the exponent up here. Now I would like to combine these, but there's a problem. This has an x to the 2n plus 1 power. This has an x to the 2x minus 1 here, and this has x to the 2n plus 1 here. So we have to adjust things here. So I'm going to adjust it actually so this one looks like this over here. So I'm going to do the following. Okay, so I'm going to make the substitution here. I'm going to let k minus 1 equal n. That means k would equal n plus 1. I'm going to make that substitution up here. So if n starts at 0, then putting 0 here, k is going to start at 1. So in place of n, I'm going to write k minus 1 everywhere. And on this one, I'm just going to make the substitution n equals k. So therefore, just replace all the n's with k's here, and it'll be k equals 1. So making that substitution, we get then, on these things, we get... Okay, so making a substitution, so I'm putting k minus 1 in place of n here, 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 and here. That's what I've done. Down here, I should be k minus 1 here. That's a mistake here. So it'd be minus 1 to the k minus 1, x to the 2 times k minus 1 plus 1, then over 2 to the 2k minus 1, then k minus 1 factorial squared. And here I'm just replacing the n with the k. And this summation now starts at 1. When I simplify this here, it's going to end up being actually x to the 2k minus 1, so these will have the same powers on the x, these two guys. So let me simplify this a bit here. So doing that, we get... Okay, so simplifying, you got negative 1 to the k times negative 1 to the minus 1, which I have here. Then if you multiply this 2 in, it'll be 2 to the k minus 2 plus 1, so it'll be 2k minus 1. And then this will be 2 raised to the 2k times 2 to the minus 2, which I have here. Okay, the minus 1 to the minus 1 power, it's 1 over minus 1, which is still minus 1. So you can take away this minus 1 and this one here. So let me write, and this 2 to the minus 2, you can bring the top and make a 4 up here. So let me write one more time here. Okay, so simplifies to this. So again, the 2 to the minus 2 comes to the top, become 4. And this will change to a minus, it'll be minus 4, minus 1 to the k, x to the 2k minus 1 over 2 to the 2k, k minus 1 factorial squared. Okay, so I'm out of space here. So let me erase a few things and we'll keep going. Okay, so we have our y prime plus xy now written like this. Now I'm going to pull out what they have in common. They have a x to the 2k minus 1 in common here and here, and they both have a minus 1 to the k in common. And they have a 2k in common also. And so let me pull out the summation. Let me just write it here and I'll explain what I did. Okay, so I've written it as a single sum, and I notice they have a minus 1 to the k. I pull that over here. A 2 to the 2k in common. So, and I've pulled the x to the 2k minus 1 out on this side. So on this one, what's left would be the k factorial on the bottom and a 2k on top, because the minus 1 to the k is over here. The 2 over 2 to the k is here. And the x guys over here. And this one, factoring the minus 1 to the k out, it's over here, 2 to the 2k is here, to be a negative 4 left on top, and a k minus 1 factorial squared on the bottom. Okay, so I've written it as a single sum now. Now I want to combine these two fractions, so let's make an observation. So note that k factorial can be written as k times k minus 1 factorial. Then if we square both sides, we'll have k factorial squared equals k squared times k minus 1 factorial squared. Because we have a k factorial squared here and a k minus 1 factorial squared here. So I'm going to multiply top and bottom here by k squared to make this bottom part into k factorial squared. So doing that, we get then so multiplying top and bottom here by k squared on this guy. and as we mentioned over here, it's going to be 4k squared on top, and then the k squared times the k minus 1 factorial squared is just going to change to a k factorial squared. So let me just make those changes right here. So we get this, then making those changes. Now they both have the k factorial squared here, so we can write them as a single fraction. So doing that we get then, let me just change it here again. So doing that we get then, so we get this then. Okay, and now we can, on top here we have a 2k minus 4k squared. Let's factor out a 2k. So doing that we get then, so factoring out the 2k here, so pulling it out, there'd be 1 left there, then factoring 2k out of this guy, it'd be minus 2k left there. Okay, I'm going to do one more thing now, because I want to write this as actually 2k minus 1, so I'm going to factor out a minus 1 from this. So factoring a minus 1 out over here, it would add 1 to the power on this guy here. Oh, actually we'll just keep it a minus. Let's pull a minus sign all the way out in front of the summation. So I'm factoring a minus sign out of this guy. So doing that we get then, so factoring out the minus 1 from the 1 minus 2k, it become 2k minus 1, and a minus 1 will come in front of the summation, which I have here. So the minus 1 pulled out, and switch these around. Okay, some out of space. So let me just, this is as far as I'm going to simplify this side. Okay, we want to show then that this equals x times, actually it's going to equal negative x times y double prime. We'll show in a second. So let's just summarize what we have. So let me erase a few things and we'll summarize what we have. So summarizing, we've shown that y prime plus xy equals this power series over here. And I want to show up here, see, what we need to show is x y double prime equals negative y prime plus xy. So if I stick a minus in front here, that would just take away that minus sign there. Okay, now let's take a look at x times y double prime. So we write that down here using the y double prime power series. Okay, so I'm going to go x times my y double prime. Here's my y double prime power series up here, so I wrote it down here. So multiplying the x in here, it would add 1 to this power. So let me write it here. And actually I'm going to, you multiply the x in, but I'm also going to change to k as my index here. So I'm going to let n equal k. So multiplying the x in and letting n equal k, we get, okay, so letting n equal k, so to replace all the n's with k's, multiplying the x in is going to add 1 to that, so it'll be minus 1 instead of minus 2 here. So I've done that here. I've also rearranged, so I have the minus 1 first, and then the 2k and the 2k minus 1 over here. Now, if you compare this with our negative y prime plus xy up here, you can see they're identical, they're the same. So they're the same, so it means that we verify that negative y prime plus xy equals x y double prime. So pretty much our y up here we've shown is the solution to this differential equation. Okay. So hence we have verified that the power series for y, so this guy up here, is a solution of differential equation. So our differential equation is x y double prime minus equals minus y prime plus xy. Okay, so we're done with our question, so let's leave it there.